I'm CK. Today we have another one from Axis Modular. I built their EBB a little while ago, a couple of days ago, weeks ago, whatever it is. I'll try to remember to put a link to that in the description below, but I'll probably forget. This is their Flow, and it is an LFO, probably not just a simple one. Axis probably has some tricks and techniques in store for us. So we'll put it together, see how it sounds, and I hope you enjoy the video. Let's open the box from Axis Modular in Hampshire in the UK. Picked this up from thonk.co.uk as I do many of my kits. Flow full DIY kit. August 2024, and right now is October 2024, so this is relatively recent. Cut the tape. Let's see, we've got some chips in here. We'll look at that in a minute. And similar to the last one, we've got a bag. This is pack 2 with the caps, power regulator, transistors, etc. And this one is resistors and diodes. And we've got a bunch of loose stuff. They didn't create a bag for the pots and the switches and the jacks and so on. And the knobs, kind of blue. They're not anything to write home about. They're simple press-on knobs. They've got no locking. They've got no brass inserts. Nothing interesting like that. And he gave us another one of these, which I don't know what the heck I'm supposed to do with that. I love DIY. Yes, we do. I'm getting a sneaky suspicion. Let me take a look. I'm getting a sneaky suspicion that this is the same as the EBB, just with a different chip. So let's see what we got here. Here's the front panel. It's got waves, depth, offset, frequency, a tap button, an LED, a sync, probably a jack, uni and bi, frequency, crest, trough, stir in, and the waveform and the inverse of the waveform, if you want to use that. And if we look at the EBB, we've got wave, tap, sync, uni, bi, crest, trough, forward, inverse. So it looks like he used the same front panel and just relabeled it, which is very cool. That makes a lot of sense. But I'm going to take a look at this. I'm thinking these boards are almost identical. These boards, so far, even including all the thank yous, appear to be, look at the front here, it's got the, yep, it's got the 074s on it. This is exactly the same as the other one, and it even says so on this one, EBB Flow /Flow PCB. And does this one say that? Because I didn't notice that the last time. Doesn't mean it wasn't on there. I just didn't notice it. So these are the same. I'm going to look at the ICs, and yeah. So where this one on the microcontroller says EBB, on this microcontroller it says Flow. So they're the same units. I could probably save time and pop this out and put it in there and just replace the front panel, and we'd be done. I'm not going to do that because you may not have the EBB and you came here to look at the Flow. So that's what we're going to do. We're going to build the Flow. So again, we've got resistors, capacitors, no surface mount on this, some LEDs, which are probably bipolar LEDs. In other words, it'll be red with current flowing in one direction, green with current flowing in the other direction. And what else was there? Oh, I'll talk about that when I put it together. Never mind. Never mind. And pin headers again. Since I just built this one, oh, that's interesting. He found a blue push button also instead of the green. So he's got blue knobs for the LFO and green knobs for the waveform generator. So that's it. Nothing much to be too surprised about in the parts. And since I know what's coming, we'll be able to probably get through this pretty quickly. So I'll get the soldering iron heated up and we'll put this thing together. I will admit I did think about cutting and pasting the video footage from the EBB and pasting it in here because it's going to be basically the same, but then I realized for those of you who just have the Flow and don't have the EBB, you don't care about that. You might get a little confused with what I was saying, so we're going to, and anyway, I'm going to have to build the thing for myself because I want the LFO. So we'll go through the whole thing. The build guide is available. Got a good bill of materials. Then throughout, there's some good pictures. Not great pictures. In some cases, he like zooms in too close, so you can't see it in context. But that's really a nitpick. The build instructions are, for the most part, very good, and we'll just go ahead and put it together. And we'll start with the resistor pack, and there are resistors on both boards, and there are also ICs on both boards, which is not typical. You typically don't get ICs on the pots and knobs board, just on the main board, but in this case, that's what they wanted to do, so that's what we got. So we'll open up the, and as you can see, EBB Flow Pack, EBB Flow Pack, so he's labeled them internally. I didn't notice that on the last one. Actually, I don't think I threw out the trash from that one. Let me take a look. Yeah, the other one says EBB Flow too. So, doesn't matter in the end. I just wanted to point out that it's kind of cute, and he's taking advantage of the fact that he can use the same circuitry for different purposes just by swapping the microcontroller, programming in the microcontroller, so nothing wrong with that. So we're going to start out here with the resistors, and first we're going to do these 47 ohm resistors. He has a number of low value resistors, which is interesting. The other thing he does, he has a little piece of paper on the resistors with their value, so you can easily sort stuff out and not necessarily get confused. Let me get R1 and R4 first, which are the 47 ohm resistors. One other thing I'll point out, now I can't point it out if I can't find my pointy thing. There it is. All the components on the main board start with 1 and go up from there. All the components on the pots and knobs board start at 101 and go up for there. So when you're looking in the build guide and it says go to resistor 111, you know you'll need to be on the pots and knobs board. If it says just 11, it's on the control board. And I like when people do that. Many do. Every now and again you'll find somebody who doesn't, though, and you'll say, oh my gosh, now I gotta search at semi-random. So let's see, where is R1? And again, I just did this the other day. I should be able to slap it together pretty quickly. So we'll put that in there, and I'm going to solder this one. If I can get my solder out from under my iPad. Solder this one to show you how good the board is. The board is very good. Solders very well, and you can see it wicked through the through-hole plated holes, which is very nice. Means we have a nice solid connection, and one that is not going to corrode and will be very reliable, which is why we do, one of the reasons why we do through-hole. The other reason is because it's a multi-layer board, and doing through-hole is pretty much the only way it is going to work for you. Now we'll do the 10Ks and all the rest of the resistors. There's probably about 30 or 40 resistors on the two boards, so there isn't much more to say about resistors than what I've already said. So I will be putting the cameras or the video into fast playback and mute the sound and probably cut some of it, because it's time for you to enjoy resistor time. That's resistor time for the Flow. Now we'll do our diodes. We've got 11 Zener diodes, as I recall, and we've got 2 power protection diodes. And of course, with power protection diodes, generally look where the power connector is going to be, and it's got a silver stripe on it, which will match the white stripe printed on the circuit board. Oh, and one other thing, you need to save a resistor leg, because there's a bridge, a jumper that goes here. So as you're working, just set aside 1 or 2. I generally set aside 2 because I'm often going to lose 1. So there's the 2 power protection diodes. Now we'll do all the 4148s. I think that's 4148s. I can't really see. Maybe they're not. I think they weren't. Oh no, he says 1418 diodes. I don't. They look like they're marked as 4148s for me, which is what I would expect, but that's okay. And same thing. The black line will go to the white line on the circuit board. Now one thing, the template that he used for, that the board software used, is a little big for these small diodes. So when you bend the leads, you want to bend them about 2 millimeters away from the body, not tight up against the body. Maybe even 3. But in any event, all there is to say about that. So just like the resistors, we'll go back into fast motion and mute the commentary. Now we'll put the jumper wire on. So we're taking a resistor lead, bending it down, making it look like a little staple or whatever analogy you want to draw, and put it through here. It's just a wire to jump over from here to ground. Now we'll put the socket, IC sockets on. And as I said, there are IC sockets on both boards, not just one. And again, the chips are, there are 3 TL0 TL074s, 3 74s, 1 72, and the microcontroller with the actual software on it. So what I'm going to do is I'm going to do this board first. Put the one socket on, matching the notch in the socket with the notch printed on the board. If I can get it in there. There we go. Set that one aside for the moment. Set it down. It's a little... It's not flat, so I will push it down and do one pin here and one pin on the other one. Let them cool, pick it up, look, everything's flat, we're all good, so I'll zap all the other pins down. I'll go to the other board. Since these are spread wide apart, I'll put a little card on there, slide the card out. Now they're all on, ready to solder without me having to fuss. Now we're going to put the ceramic caps on, so we're going to open up the next bin, the next bag. And that will be all these guys, all the 104s, the 100 nanofarad caps, the decoupling caps. But one thing to be aware of, and I missed this on the first one, there are two 103s, so do not confuse yourself. Most of them are 104s, there are two 103s, and I'm setting those aside right here, and I'll show you where they go when we get to it. The two 103s go here and here, C14 and C15. And that's all the ceramic caps. Now we're going to do the two foil caps, C9 and C10. And he actually, I'm doing it slightly different than what the build guide says, the order of some of these things. I'm doing it more in line with what I'm comfortable with. If you have not built a lot of these, I would strongly recommend you stick strictly to his instructions, but I've built a lot of electronics, and I built this board already, so I'm going to build it the way I feel comfortable. Now we've got a transistor, and a voltage regulator, 5-volt voltage regulator, and they both go on this board. Transistor here, voltage regulator goes, where does it go? Does it go on the other board? I don't think it does it? I'm trying to remember. We'll just put the transistor on first. Oh, the voltage regulator goes right there. Now he wants us to put the power connector on right now. That's one of the areas I'm going to skip over for right now. I'll come back to it. But now we'll do the electrolytics. There should be two. That's a 10 microfarad, and the 10 microfarad goes in C6, and there's a very clear indication of where the long plus lead goes, as well as striping, showing where the negative side goes. And now we'll do this 22 nanofarad. Got two of those, 22 microfarad at C3 and C4. And a big old, let me not get ahead of myself. Then a big old 100 microfarad. And I'm going to leave those leads unclipped while I do the power connector because my cameras are about going to time out. And this is about what we're going to do for tonight. So I'll put the power connector on. It's keyed. It's got a slot. There's a mark for the slot on the board. And there's a negative 12-volt line, so you can double check that the red line goes to that. Unfortunately, when you put the connector on, it covers that red line, that white line up. But if you always use keyed connectors, you won't have a problem. If you don't use keyed connectors, you might have a problem. So just be aware that you can't see the line once you put the connector on. And I will solder these leads, then I will go in and feed the cats, and we'll go start on the pots and knobs and so on when I come back. And we'll talk about these LEDs because there's some interesting characteristics about them. But for right now, that is it. I gotta go feed the cats. Got our electronics bags done, so we can get rid of those. And now we're moving on to pots and knobs and other various things. And I'm going to be going a little out of order from what there I am. A little out of order from what the build guide does, and this is just based on my experience. It doesn't change anything. I'm sorry, I should have pushed these together. It doesn't change anything significantly. I just like to do things in a particular order. Where is my other strip of pin headers? Oh, I already stuck it in the board. I'm such an idiot. So I'm going to do the pin headers first. He waits quite a while longer to do the pin headers. I'm choosing to do it now just cause. One thing, both boards have the word top on them, so you know how to put them together. And I'm going to be taking this back apart after I solder these pin headers. I just like to get the pin headers out of the way, and as is my habit, I'll do one pin on each just to lock everything down, and now I'll do all the pins. And those are all the pin headers. So I'll take it back apart. Now we'll load this all up with all the componentry it gets. First thing I'm going to do is put this spacer on, and the screw goes right here under the depth pot. The depth pot is going to sit on top of it. So you want to put it on there before you put the pot on. Makes sense, right? And I'm just going to tighten it without tightening it too much because it's plastic and very easy to strip the threads. One thing I do want to show at this point, on the LEDs, these are, as I use my little LED buddy, which you should get. It's a kit. You should make it and get it. It's very handy. If we test the LED, it's red, 2.1 volts red. But if we reverse the polarity, it's green. So he uses that to tell you whether something's unipolar, bipolar, or whatever. And as we do that, I'll talk about it later. You don't put these in with the regular positioning with the long lead on plus. You do it the reverse because he wants the current going a particular way to light the color red or green depending on the signals he's sending. Now we'll put the pots on first because that's what I like to do. And they are all the same value. Now here's the push button, and it's got a flat side, and there's a flat side on the printing on the circuit board, and you want to of course make sure those match. Now I'm going to set all the jacks in place. Now we will put the one switch in. Doesn't matter which way it goes, it'll figure it out. I'm not going to put the LEDs, well, I guess I could. Actually, what I'm going to do is I'm going to put the two op amps in here right now. Changed my mind on assembly, but I want to put the front panel on just once, not put it on and take it back off. So I will do this. Oops, of course a jack went running off. Put my errant jacks back on. Switch in. Now again, the LEDs go with the short leg in the plus, not the long leg as you typically would do. That's because he wants the green light to come on with the plus there instead of the red side. Now we're going to get the front panel and set it on. Sets on pretty well. There's good clearance on the holes. Get my little clamp. Clamp that for right now, but first I'm going to put next I'm going to put the panel nut on the big pot with my 10mm socket. Then I'm going to put the panel nut on the bottom stir jack just loosely. I'm not going to even snug it down yet. I'm just putting it on there so I have it ready. Now I'm going to solder the big pot. Make sure everything is still right. Good. It's all right. And with that soldered, I can actually get rid of that clamp. But first I'm going to solder the stir-in jack I did. And take my little knurled nut tool, tighten that down. Now we can get rid of the clamp. And we can do a whole bunch of soldering. Let me flip this over, make sure, see if I can get the holes lined up in something here. I have to deal with it that way. So I am not going to do the LEDs right yet. we'll talk about that after I get done soldering all this stuff. So on the other one I built on the EBB, I flush mounted the LEDs. This time I'm not going to do that. I'm going to go all the way through hole, so they're through the front of the panel. So that is all the soldering for this kit. So before I do anything else, I'm going to go through the little card and look at all my solder joints. Oh, see, that's why I do this, because I completely forgot about the push button switch, which needs a little foam underneath it to keep it pressed down. And that's why I go through and double check, because that would have been embarrassing. Okay, let me make sure that's fully down. So I push it down, reheat that joint. Ah, you might have heard it click, because it did want to go a little further down. Now we can get rid of that foam. Okay, so that was fixed before it caused us a problem. I'm looking for anything else that may not have gotten soldered or may have been bridged or something like that. Look at the other board for the same characteristics. All good. So that means I can turn the soldering iron off. I'm going to put the chips in the other board here. The 10774 quad op amp, make sure the notch is right. Then the 072 dual op amp. Move that one in a little too much. Get my needle nose out and spread it back out. Just a hair. This doesn't have a notch, it has a circle. Then we put the Flow programming chip in it. Again, I could put the EBB chip in it and it would make it an EBB, but this time it's going to be a Flow. There's that. So what we can do now is mate the boards. Oops, can't mate the boards with this screw and the spacer still in it. Now we'll take that screw, get my screwdriver, screw the boards together, and again, do not tighten this too much because you'll just strip it. Just snug it down. Now, the exciting part, putting all the panel nuts on. Now, there are 4 hex nuts that go on the output jacks, crest, trough, and the 2 waveforms. I don't know why he chose to do it that way, but he did. And the other ones are regular knurled nuts. And now we will put the the knobs on the potentiometers. Make sure it moves smoothly. It does. These are a little simply aesthetic because these black handle guys don't need caps, but makes the color the same. And that is that. Let's double check everything moves smoothly. Yes, it does. Switch moves, push button pushes. There's the front, it's the side, the back, the other side, the top, and the bottom. Now we're ready to put it in the rack and get it pulsing its little LFO's heart out. Alright, we're in the rack and everything's powered on because I wanted the oscilloscope to get up to speed, and I run them off the same power strip, so it's up and running. One thing I did a little differently here, and I did this in the last video and I'm refining it, is I have the unit all the way to the right of the screen and I'm offset. I'm not straight onto it, because I realized my hand was usually in the way when I was twisting knobs. So I said, I'm going to try this. Leave feedback if you like it better this way, if you like it better with the straight on view, whatever works for you. Now I'll bring the scope up and making sure that's all in focus. And it is. And as you can see, nothing is going on the scope right now. And there's reasons for that. Science. Oh, one thing, you can see we're pulling about 30 milliamps on that with a peak of 114 when it started out. But that's not terrible. It's because I have depth all the way out. Now, if I bring depth up, watch the scope, you can see now you're starting to see some humps in there. There we go. I have the rate really low. So you can control the amplitude or depth of the wave, which is interesting. I'm going to turn frequency up. There's a nice little frequency. Turn it to unipolar. Back to bipolar. Now I'm going to offset, and you can't really see that because that would matter if we were doing sync. Let's see, let me change some waveforms. There's a different waveform. Now it's kind of squaring off. Now it's a sine wave. Now it's a kind of peaky wave. And then it's going over here, and I don't know what the heck that is. Let me set depth all the way up. I don't know. Turn frequency. Oh, well, that's kind of a randomy way. Oh, it is. It's supposed to be randomy. Okay, well, that's good. So it is actually doing something. So I'm going to go ahead and make some actual sound happen here. If I can figure out what I'm doing here. I should actually have some sound coming out. Okay, I'm going to use this LFO to trigger the VCA that this oscillator is into. Turn depth all the way up. I'm just working on a single note right now. You can see how that waveform operates. Let's turn it to unipolar. Back to bipolar. I'll stay in unipolar for a minute. Now I'm going to go back to a more traditional wave and reduce the depth, reduce the frequency. And you can see it climbing. Now that's a pure-ish sine. A nice quick release. A reverse of that. But we can also do a reverse simply by switching this. And that really went. I don't know what that did. I don't know why that's not giving me what I expected. There we go. Go back to that, and then I'm going to do crests only. And troughs only. And trough's not going to give us anything right now. Let me flip it to uni. It's still not giving us anything. I'm not surprised. No, it's not getting anything out of the troughs. Now let's try some other stuff from another LFO into it. I'm going to actually make this oscillator. Oh, I'm turning the wrong knob. So let me take another LFO and plug it in here. We can change frequency with that. Okay, that's a little confusing. I'm going to stick with one note. Change in frequency, but I can also go straight over here into sync. Now I'm completely synced with this external LFO. Huh. So I guess it's doing both. I'm not quite sure why it would do that. I would expect this to override the tap button. But let's see, by the way, let's do tap, see if it actually remembers a tap. 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. Yeah, it picked up my tap pattern. That's good. I'm going to move this up a little bit. What else do we want to do? I'm going to go all the way here, and we're going to take my little voltage injector and go into wave. And as we change the voltage going in there, that's 1 volt, change the waveform. 2 volts, another waveform. 3 volts goes to the other waveform. 4 volts. So that's how you can control what wave is being sent with external voltage. I do like this chaotic wave. And the ability to change the depth is interesting. I'm going to try something else here. Let me swap around some cables. I'm going to change the LFO, the VCA to regular, to my other LFO. Now I'm going to take the output of the waveform and put it into frequency modulation on this oscillator. Reduce the frequency so you can hear it frequency modulating. Now I'm going to do something that I don't know what it's going to do. I'm going to reduce the depth. So you can hear how it's not affecting the frequency modulation as much. As we take the depth out, with it all the way out, it goes completely away. We can go really deep, halfway deep, quarter deep, no deep at all. Let's try this with a sine. So that's an interesting behavior. can give it just a little bitty frequency modulation, or a whole lot of frequency modulation. So you can see how that could work for a lot of things in a filter or something like that. So that's what it does. It's a good little unit. And, oh, let me try the mix in. I forgot about that. So I'm going to go ahead and do frequency modulation. And now I found some interesting behaviors with mix-in on the EBB, or stir-in. And now I'm stirring that in from this LFO. Oh, that's just a pulse. I'm going to go with a wave. So you can hear it changing it a little bit. Let me go to the bottom mix stir in. Okay, the stir-in isn't as dramatic on this one. So that's with basically nothing being stirred in. Now I'm going to speed it up. So you can hear it affecting the waveform coming out. So again, that's it. It's a good little LFO. It's a little unfortunate that I'm only getting one output and the inverse of that output, but I guess that's okay. Lots of waveforms, lots of control. Depth control is really nice. Offset, you've seen in other products, I'm sure, that you know what that's about, offsetting the trigger for the waveform. And as you saw, pretty straightforward build. The build is identical to the EBB, just a different chip and different color knobs and different printing on the faceplate. But obviously, they do different things. So that's a good unit from Axis Modular. I'll try and do some more from them. And I hope you enjoyed the video.